Hello, so welcome back to the second part of the discussion for MRSM Chemistry Paper 2. So now we are going to continue with the discussions for question 6. Okay, so this question is related to diagram 6.1 shows the flow charts for a series of the reactions to produce the compound Z. Okay, so here it is the compound Z. So let's look at this diagram. So this is a pineapple, and the reaction between the pineapple and yeast will be reaction 1, and they are formed a compound known as compound X. So let's highlight this compound X using the yellow color. And then this compound X will undergo the reaction 2 to form this C2H4O2. So if you don't know what is this, so let's draw out the chemical formula together. So it will be, since it has 2 oxygen, so we can assume or we can predict that this is actually a ethanoic acid. So let's see if I draw this correct or not. So we have 2C in this formula. So this is the carbon number 1 and carbon number 2. And I have 4 hydrogen in the formula. So when we draw it out and we count it, 1, 2, 3, and 4. And lastly, 2 oxygen, which is by drawing like this. So we can know that this is actually a ethanoic acid. So the reaction between the ethanoic acid and the propanol is known as the reaction 3. And it will form the compound Z. So first of all, name the reaction 1. So what is the reaction 1? So inside the pineapple, it is fruit, right? So it has the sugar known as the glucose. So the reactions between glucose and yeast will be fermentation. So we can assume, so we know that the reaction 1 is actually the fermentation, and it will form the compound X. So the answer for A1 will be fermentation. Okay, write the chemical formula for the compound X. So here already asked you to give the formula, so you cannot give the name, because in this question it wants to test you whether you know what is the chemical formula for the compound X. So the reactions between glucose and yeast for fermentation, it will be, what will be the product? So test yourself. After this glucose, this is the chemical formula for the glucose, and then this is the fermentation reaction 1. After it get fermented, it will form the ethanol, which is C2H5OH, right, with the carbon dioxide, because it is a fermentation process. So if you want to balance the chemical equation, you can balance it. So let's see. Okay, we have 6 hydrogen at the back over here. So here in front we have 12, so we can put 2 glucose over here, and then put 2 for the carbon dioxide. So let's see whether this equation is balanced or not. So we have 6 carbon over here, and at the product side we have 2 times 2 is 4, 4 plus 2 is 6, and then oxygen we will have 2 times 1 equals to 2 plus 4, which is 6. So okay, so this is the balance equation. So the chemical formula we want to put for the compound X is surely this one, the ethanol. It's not the carbon dioxide, remember? It is not the carbon dioxide. Okay? It is the ethanol. So the chemical formula for compound X is ethanol. So in over here you need to write it as C2H5OH. Don't write the words ethanol, because it wants you to give the chemical formula. Okay, B1. Suggest a suitable reagent to carry out the reaction 2. So let's see what is reaction 2. Reaction 2. Okay, so we already know that compound X is the ethanol. So ethanol undergo reaction 2 will form the ethanoic acid. So you need to know what is the conversion process and the reagent needed to form ethanoic acid from the ethanol. So in order to let the ethanol become ethanoic acid, you need to do a reaction known as the oxidation. So if you want to undergo or carry out the oxidation reaction, you need oxidizing agent. So the answer for this question, you need to list out the oxidizing agent. So let's see what is the oxidizing agent. So the oxidizing agent for this question, you can put it as acidified potassium manganate solution, where the chemical formula will be KMnO4. If you don't want to write the oxidizing agent for this is acidified potassium manganate, you also can write it as acidified potassium dichromate solution. So it will be the formula K2Cr2 or 7. Okay, so question B2. State the observations based on your suggestion in 6B1. So this question is related to the question above B1. So if you already write the answer for oxidizing agent is the acidified potassium manganate, you need to write the observation based on this acidified potassium manganate, which is, we know that this acidified potassium manganate is actually purple color. So when the oxidation process occurs, this purple color will become colorless. So for your information, the color changes for the oxidizing agent is very important, so you need to remember it very well. So for example, if you write the answer is the acidified dichromate solutions, the color changes will be orange to green. So you don't get confused for the color changes. So basically, I personally prefer it to remember the acidified potassium manganate, because the name is more easier to remember, and you also need to just remember the color purple will just fade and get colorless. Yeah. So state the observation. And one more thing is that students, you need to remember that when you want to write the observation based on the question over here, based on the suggestion in the previous answer, you need to take note that if for color changes, you need to remember you should write change from what to what, change from what color to another color. Don't just straight away write the color of the potassium manganate solution is colorless. No, this is the wrong answer, because the original color for the potassium manganate is purple color. So for the observation, you must write change from the original color to the from the original color to after what it changed to. Okay, so C, propan 1O is added in the reaction 3 to produce a compound Z which has a sweet and fruity smell. So this is already give you a very good hint, where you only know where in your syllabus in your Form 5 chapter 2. Yeah, the only organic compound that has the fruit and sweety cell is actually the ester. Okay, so let's look at C1. Propan 1O is one of the isomers for propanol. Identify the isomers for propanol. So we have two number of isomers for the propanol. So how I know that? So let's draw out the original chemical formula for propanol, which is C. We have C, 3C, and then one OH group, and the other one which I didn't draw out. Okay, let me draw out. It is the original propanol. It is the chemical formula for propanol. So if you want to name this one, this is actually a propan 1O. So if isomer, you already know what is isomer, right? Which is they have the same molecular formula but different structural formula. Just So it means that they have the same formula, just that how the arrangements of the atoms for the isomer, it will be different. So I can move this, right? So because this is the only different things that I can move. So let's see how can I move it. So if I want to put this hydroxyl group at the second carbon, isn't that this is also another isomer, which is we name it as carbon 2-ol. No, carbon 2-ol, the propan 2-ol. Sorry, my mistake. Because this hydroxyl is at okay, some of the students will ask why the number now is 2, because it is at the carbon number 2, 1, 2, 3. Or even you want to start from right to left, also the same, 1, 2, 3, it doesn't matter. So you still get propan 2-ol. So isn't it that this chemical formula is the same, right? The same chemical formula, but they are the different compounds. That is what we call it as isomer. Okay, so let's look at question C2. Draw the structural formula and name compound Z. So you need to draw first and then you name. First draw and then you name compound Z. So compound Z is the ester. So let's look at what is the reactants. Okay, we have the reactants, which is the ethanoic acid over here, and plus the propan 1-ol. So what will be the compound Z? Okay, so first we have the carboxylic acid, which is the ethanoic acid, and then we have the alcohol, which is the propan 1-ol. Right. So let's draw out the chemical formula for the ethanoic acid first. So it is C double bond OH, and the other side is the H, the hydrogen. So okay, let's erase, put this away first. Okay, and the chemical formula for the alcohol, which is the propan 1-ol, would be CCC, because it is propan, so it has 3 C, and 1-ol is because the hydroxyl group is at the carbon number 1. So no matter if you start from left to right or from right to left, it's still the same. Okay, so how are we going to draw for the reactions? So you need to remove the H over here. And then for ethanoic acid, which is the carboxylic acid, you only need to remove the hydrogen. So let's cut it over here. And then for alcohol, you need to remove the hydroxyl group. So let's draw a black line, cut it over here. So do you notice that this highlighted H and another OH, actually they can aid and become the water, right? This is the byproduct. So students, you need to understand first before you memorize it, or else it will be very difficult for you to memorize the fact one by one. So I will always encourage you to understand first and then you practice. So this cleavage over here, we can join it, right? So let's draw it. The chemical formula, the structural formula for the ester would be, okay, just copy down all these things that haven't get cutted, and then you draw this first. So let's go one by one. Okay, so another one, which is we want to draw for the alcohol, which is over something over here because we cut this already. So let's connect it with a C, 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 and then here we have a H, 2H, and the other parts will be H. So this is the ester. This is the compound that we form. Compound Z is the ester. For the name for the compound Z, it will be propyl ethanoate. For your information, the naming for the ester, in front we use the name for the alcohol and end with something like YL. Lastly, for the second part of the name for the ester, it will be derived from the carboxylic acid and end with OATE. So propyl ethanoate. So let's say if today I use a ethanol and a ternary acid to make the ester, what will be the answer? So what will be the ethanoate? So what will be the answer for this ester will be, if I react this with this and then form a ester, what will be the naming? So the naming will be ethyl SAM. Copy down the in front the prefix and then end it with the YL. Lastly, copy down the name for the carboxylic acid with ethane, and then the backwards you substitute it with NOATE. So the naming will be ethyl ethanoate. Okay, so 3. Diagram 6.2 shows two methods. Okay, we have two methods that can be used to carry out the reaction 3. So this is the method 1, this is the method 2. Okay, reaction 3 is basically just like just now, we make the process of making the ester. So okay, we want to make ester. Reaction 3 is make ester. For method 1, we have the light big condenser, and then we have the reactants, water, heat. But at the right hand side, we only have the H2SO4 heat directly. Okay, so the question already gives you method 1 is more suitable to be used compared to the method 2. Justify the use of the method 1 and explain your answer. So this question is quite good because it already gives you that method 1 is more suitable than the method 2. So you need to choose method 1. However, you need to justify, you need to give the reasons why method 1 is better and explain your answer. So do you notice that we have a water bath over here, right? I believe in your school, when you do the experiments, your teachers will also advise you to put it in the water bath. So the reason to keep the water bath is because this propanol is actually highly flammable. Propanol is an alcohol. So the characteristic of alcohol is actually very flammable, means that they can burn very easily with a very big flame or huge flame. So the heating of the propanol must use water bath method to control it, to avoid, and you can add your answer longer, to avoid explosion. We cannot directly burn the alcohol or else it will explode. And then the second answer would be, okay, propanol is volatile. It means that it can evaporate very easily. So this propanol vapor is condensed to the propanol liquid to flow back into the round bottom flask to react completely with the carboxylic acid. So I will explain what is meant by this. It is basically just because like when you burn the alcohol, it will evaporate, right? So when the vapors go up and it touches the cool surface of the light condenser, because it has the water inside it, water will provide a cooling effect. So when the vapor touch the cooling surface, it will condense, right? Condensation, it means by the vapor will change back to the liquid form. This is what we call it as condensation. So in order to not waste this propanol, we will use the round bottom flask to react the alcohol that has been evaporated and back to with the carboxylic acid to produce more ester, so that it won't get any wastage. Okay, we are almost done for the discussions for this paper, MRSM paper 2 discussion. So let's continue with question 7. So this is the table 2 that shows the information about the electron arrangements for the atom D, E, and G. So the letters D, E, and G do not represent the actual numbers of the atoms. So first, what is the meaning of the valence electron? So this is the definitions that you must know, which is valence electrons are the electrons that are in the outermost shell, meaning the shell that is at the last round of the atom. For example, like this atom D, it has 1, 2, 3 shells. So this is the valence shell, and the electrons inside it is the valence electrons. So A2, explain the difference in size of the atom D and E. Okay, So actually they are both have the 3 shells. So how I know is because it has 3 numbers like this. In the electron arrangement it has 3 numbers. So it means that this atom has 3 periods, which is also equivalent to 3 shells. So we know that actually this is from the group 1 and this is from the group 17. Actually, in this question, this particular A2, it is asking you about the periodic characteristic across the period 3. So this is actually quite famous also, and usually you will come many examiners like to ask this kind of questions. So this question is asking you explain the difference in size of the atom D and E. So we know that in the periodic table, the size of the atom, if we go from left to right, it is decreased. So for group 1, which is located at the left side, and then for group 17, which is located at the right side. So the atom size for D will actually larger than the E. So if you want to explain it like this also can, which is the atomic size of E is smaller than the D. Why? Because the nuclear attraction force towards the electrons in atom E is stronger. So how we can say this is because even though, okay, this atom D, it has 13 proton number. No, it has 11 proton number. But for atom E, we have 17 proton. So it means, this is what it means by nuclear attraction force. Because when across the periods, the number of the protons will increase 1 by 1 per element. So that's why the nuclear force of attraction towards the electron, because you have more protons, so you can attract more electrons towards the nucleus. That's why the size of the atom E is much more smaller than the atom D, due to the stronger neutral attraction force. You need to imagine that this proton is actually, because it carries the positive charge, so it can attract the electrons with the negative charge to get closer to the nucleus. So once the electrons get closer to the nucleus, the size will become smaller or decrease in the size. Okay. So the gas of element E is channeled into the water to produce a solution. Predict the observation when a blue litmus paper is dipped into the solution. So let's go what is E. Okay. So just now I have analyzed that this atom E is probably come from the group 17, which is the halogen groups. So we know that halogens include fluorine, bromine, iodine, right? So it will form the acidic solution when it dissolves in the water. So when I put the blue litmus paper into the solution, which is the acidic solution, what will be the observations? So the observation will be the blue litmus paper will turn to red and then bleach. The bleach means suddenly it decolorizes. So actually it has 2 color changes, which is first, it changed from blue to red, and then from red, it become colorless. This is due to the bleaching properties of the group 17 elements. So actually, the atom E is chlorine, because you can count the number of the electrons, and then you find it on the periodic table to see what is the elements that contain 17 electrons. For information, the number of the protons is always equals to the number of the electrons. Okay, so let's continue with question C. Diagram 7 shows the observations when the element D and G react with the oxygen gas, which is the oxygen O2. So the size of the flame for element G is bigger than the element D. It has a larger flame. Explain the difference in the observations. So first of all, you need to mention about reactivity. Why? Because the reactivity of element G is much more higher than the element D. That's why it can produce a bigger flame. So the answer would be G is more reactive towards the oxygen gas then D, and then the nuclear attraction force, just like what I mentioned just now, nuclear attraction force towards the valence electron is weaker. Therefore, it can react with the oxygen more vigorously. Yeah. Okay, write the chemical equation for the reaction between element G and oxygen. So element G is actually a metal, right? Because it also comes from group 1. So how I know this atom is come from group 1 is because I look at this number, which is number 1. The valence electron, which is the last number will be the valence electrons. So it has only one valence electron, therefore it is come from the group 1 element. So this G, when it react with the oxygen, it will produce the metal oxide, because G is actually a metal. So G will form a positive charge and oxygen will form negative 2 charge. So if I want to write the chemical formula for the metal oxide, because it reacts with the oxygen, that's why it is a metal oxide. So G, let's copy down the G, and then copy down the opposite charge of it, and then copy down the oxygen, copy down the opposite charge of the G, which is 1. So we usually do not write out this 1, so the answer will be G2O. However, you need to check whether this is a balanced equation or not, or else you will deduct marks. So okay, how to see whether the equation is balanced or not is like this. We have 1G at the left hand side, but we have 2G at the right hand side. So if we want to balance it, we need to put it as 2, so that the left one we have 2, right one we have another 2 also. So left one we also have 2 oxygens, but over here we have only 1 oxygen. So we want to balance for the oxygen, we will need to put a 2 over here. You know that now, okay, I put a 2 over here, so now my G also not balanced again, because left is 2G, right is 4G. So erase these 2 and then write 4. So isn't it this already balanced? So this is how we balance the chemical equation, and this will be the answer. Okay. The third question. So calculate the mass of the compound form when 0.1 mole of element G reacts completely with the oxygen. Relative atomic mass all equals to 16, G 13. G is 39. Okay. So the reason why balance equation is very important, because once you didn't get this balance equation at the part 2 here, then you cannot calculate for this question, and this question is 2 marks. Even though maybe you think, never mind, it is not many marks also, but marks is always very important. Or else, maybe sometimes you just less 1 or 2 marks to become an A, right? Okay, so based on the question, it says, when 0.1 mole of the G element reacts completely with the oxygen, what will be the mass of the compound form? So we want to calculate for the mass of the compound, which is the G2O. Okay, so in this part, according to the equation, we have 4 moles of G, that equivalent to 0.1 mole, right? The coefficient of it. So the number of mole of G will actually be like 0.1 mole divided by 4, because this coefficient 4 stands for 0.1 mole, right? Okay, don't put the moles or else you will confuse. For 4 parts, can say like 4 parts lah. 4 parts of the G will become stand for 0.1 mole. So divided by 4, we will get 0.025 mole. So always according to the equation, according to the chemical equation, the number of mole of G2O equals to 0.025 mole times 2, because based on the equation, you have these two coefficients, because 4 parts of the G will form 2 parts of the G2O. That's why you need to times it with 2. So you will get 0.025 0.05 mole of the G2O. So I want to calculate for the mass. You need to remember that mass of G2O will be equals to the number of mole times the molar mass. So how to get the molar mass? It is the relative atomic mass. So 0.05 times 39 times 2 plus 16. So the answer will be 4.7 grams. So this will be your answer. So the answer will be 4.7 grams for the mass of the compound form. Okay. So let's continue with question 8. So this is a question I believe most of the students will have that because it is quite complicated. But once you understand the concepts behind it, actually it is easy. Okay, for diagram 8.1, this is the apparatus setup that investigate the effects of the metal X and metal Y on the rusting of the iron nail. So you know that this is actually the redox reaction. Rusting of the iron nail is the redox reaction, and this is what it always likes to come out in your exam. So we have two sets of apparatus, set 1 and set 2. Set 1, we have the iron nail wrapped on the metal X that wrapped on the iron nail, and we have the jelly solution plus the potassium hexacyanoferrate 3 solution. And set 2, we have also the same apparatus, just that one is the metal X, another is the metal Y. So the result of the experiments after 3 days is shown in the table 3. Set 1, the blue spot form. Set 2, no change. Okay, let's go with the first question, A1. What is meant by redox reaction? Rusting of the iron is a redox reaction, and what is meant by redox reaction? So redox reaction, the definition you must remember because it also always like to come up in the exam. So let's go. Redox reaction is actually the chemical reactions where the oxidations and the reduction occur simultaneously. So what is meant by simultaneously? It is the meaning that these two reactions, oxidation and reduction, will occur at the same time and at the same seconds. Okay, 2. Based on the observation in table 3, suggest the metal X and metal Y according to the standard electrode potential provided on the page 41. Okay, simply so you just need to put the examples that you think what is metal X and what is metal Y. So we need to base on this diagram. So the blue spot is formed. So actually we need to know what is the blue spot actually. This blue spot is actually due to the ferrum 2 ion. So when you put this ferrum 2 ion in the potassium hexacyanoferrate solution, it will become dark blue color. The whole solution will turn dark blue, and this is the chemical formula for the potassium hexacyanoferrate 3 solution. Yeah. So when this iron 2 ion react with this, they will form the blue spot. So now you will ask, why this? So how does this iron 2 ion comes from? No, where does this Fe2 plus comes from? It is come from because the iron already rust. Where does the Fe2 plus ion comes from? Because your iron is already rust. Iron is rust. That's why your iron ionizes to form the Fe2 plus ion and release 2 electrons. So now we already know that this observation is due to the iron is rusting, right? So how are we going to know what is the metal that will cause the iron to rust? Is because the electron that cause the iron to rust is because there are less they are more electropositive. That's why the ion will no, they are less electropositive, sorry. And another side will be more electropositive. So you need to check your standard electropotential, and then you check what is the value for the ion, and then you just simply put the metal that is, so for the metals that is higher than the location for the ion, so the ion will not rust. Means while if the metals that are located at a position lower than the ion will rust. So the answer would be metal X will be the tin, lead, and copper, and then metal Y will be magnesium, aluminum, and zinc. Yes, yeah. So metal Y will be magnesium, aluminum, and zinc. So explain the observation that obtained in set 2, which is what I mentioned. Why you in set 2, right? So in set 2, the observation is no change. It means that rusting is not occur because the iron 2 plus ion is not present. So 4, arrange the metal in the ascending order of electropositivity. So for sure, X, Fe, and Y. So for the metals that is less electropositive, it will cause the rusting takes place more easily. And then when you go towards the, like ascending power, which is go to the more electropositive, so the rusting will not happen. Rusting will not happen. Okay. Next, question B. Diagram 8.2 shows the apparatus set out of an experiment to investigate the transfer of electrons at a distance. So for information, this is also the questions that always come out in your exam, where it always asks you the topic on the transfer of electrons at a distance. So what is actually mean by at the distance? This distance is actually created by this dilute sulfuric acid, because according to the apparatus set out, this is the carbon electrode P, and this is the carbon electrode Q. This is the solution X, and then here provided you a iron 2 sulfate. So actually your electrons need to overcome these distances in order to connect with another electrode. That's why you will only have the voltage. Yeah, that's why only you will have the voltage. That's why that's what it means by at a distance, because your electrons need to travel through the distance of the dilute sulfuric acid, and then goes to the another side, and then to conduct the electricity. Okay, so let's go with the first question. Suggest the solution 8. So for information, the question already give you the iron 2 sulfate. Therefore, and this is a redox reaction, right? So for your information, you need to always remember iron 2 solution. This is the keywords. This is the main character. Iron 2 ion is the reducing agent, right? It is the reducing agent. Means that this solution over here, it must be something that is oxidizing agent. So isn't it? This is the question that is also similar to the question 6 just now, that suggests you they ask you to suggest the solution X. So you need to know solution X is the oxidizing agent. So the answer you can write is anything that is under the category oxidizing agent. For example, chlorine water, bromine water, KMnO for acidified potassium manganate, or acidified potassium dichromate solutions. Okay, write the half equations that happens at the electrode P. So this is the carbon electrode P, and this is the oxidizing agent. For sure, it will undergo, so oxidizing agent, it will oxidize this iron 2 sulfate, but it will get reduced. So if I ask you to write the chemical equation, it will be Cl2 plus 2E plus become 2 chloride ion. This plus 2, you accept electron, right? So accept electron means it is the reduction. So it is matched with the roles of the oxidizing agent. Oxidizing agent, you will oxidize the other people, but you yourself will get reduced. It is kind of like opposite. Okay, the last question, I guess. Yes, the last question, the third one. Explain briefly the chemical test. Okay, this question is asking you chemical test to identify the presence of the ions formed at carbon electrode Q. So since this one, it will get reduced, right? Reduction is actually happen at the P. So carbon electron Q will get oxidation, right? So it will actually form Fe2 plus. It will form, it lost one more electron, and then it become Fe3 plus electron plus 1 electron. So we are going to actually identify the presence of this ion, right? Explain briefly the chemical test to identify the presence of the ions that form at the carbon electrode Q. Because this one, it get reduced. Over here, it accept electron, so here for sure it donate. Oxidation is lost electron, meaning it donates the electron. So it donate electron, it will form the Fe3 plus ion. So where are we going to identify the chemical test? The Fe3 ion 3 plus ion is by the chemical test, which is so first, add a few drops of the NaOH solution, or if you want to use the ammonia aqueous solution also can. So you add this NaOH or ammonia aqueous solution into a test tube until excess and containing the solution at the electrode Q. And then a brown precipitate will form. This brown precipitate test, it shows the presence of the Fe3 plus. So if there is any presence of the Fe or iron 3 ion, so it will form the brown precipitate. So if you want to test whether the presence of the ion that form, which is in this case we want to test Fe3 plus, right? So you just like collect some solution over at here, and then you pour it inside, and then you add again NaOH until in excess. Lastly, if you see anything that is brown color, it shows the presence of the Fe3 plus. So congratulations, because we already discussed for the paper 2 questions, structure questions completely. So thank you for your patience to watch until the end of the video, and thanks for watching. And you can also help to share and like the video to your friends if you find this video is useful. Thank you.